Okay, so welcome everybody. We're here to really talk about a little odyssey, and a little odyssey that was brought to us by that person. No, that wasn't the person. Was brought to us by Alan Lewis. Alan, who came to a digital SIG a couple of months ago with his little 6 by 6 inch etching laser, and really got us intrigued because those of us who love lasers would very much like to have one, and yet the thousands of dollars or the large spaces they require really, our spaces aren't conducive to that in many instances. So he brought this thing in and really got us interested in the notion of what was possible. So I'm going to go ahead now and I'm going to switch to my PowerPoint presentation and we will get going here. Okay. Is that Susan? Is that you?
I think it's Bill Bloomberg's mic that's on.
Ah, okay. Bill, would you mind muting, please? Thank you. Okay, I see the back of Alan's head. I'm trying to find my other screen here so that I can, there we are. Okay, so let's go ahead and share my screen, which in this case is this presentation. Again, it's about the Ortur laser, and it got us started down the path when Alan made that presentation. When we finished that presentation, we kind of appreciated the difference between a diode laser and what we have in the shop, which is a CO2 laser. CO2 laser takes a big old tube, takes a big space. There's no way to really get it down in size much, but when you go to a diode laser, you end up with a much, much smaller form factor, and you end up with less power, but for etching purposes, not bad. So the diode laser idea kind of got us excited. People started talking about what would we want to do if we were to do something like this. And some of the criteria that came up were to include allowing light burn to control it, because the one that was shown to us, and most of them on the market, frankly, were not controllable by light burn. And we were all familiar with light burn. So of course, we wanted to be able to use what we knew. In addition, one of the things that blew our mind months ago was that light burn could actually do what we call grayscale. So you could go from very light colors to very dark, very light burns to very dark burns in real time, dynamically. That's done using something called pulse width modulation, or PWM. And we wanted to be able to have that so we could do grayscale with our little laser. At the time, we were shooting for a cost range between $250 and $350. And so that was the course outline. Light burn driven diode laser that would also support grayscale and would be in that price range. But once you've made that decision, there are variables you have to fiddle with. And one of them was the power of the laser. Now, we had a bunch of people in the shop who had lasers of one form or another. And in the diode lasers, we heard everything from 2.5 watts to 20 watts. Now, just for clarification, when we talk about watts with diode lasers, we're not talking about the same kind of watts that we're talking about with the CO2 lasers. We have two 100-watt lasers in the shop and a 40-watt laser. If we were to take these diode lasers and use the same comparison, a 15-watt laser would be like a 4 to 4.5-watt laser. So take 1/3 of the number. A 20-watt laser would be like 16.6, whatever, watt laser. So we're not talking about lots of power here, and the real concession we're making. But within the world of diode lasers, we can choose something that goes from 2.5 watt, or let's call it 1 watt to compare to the CO2 laser, or as many as 20 watts, which compares to around 20 divided by 3, 6.6, let's say, watt laser if you're comparing it to the CO2. So we had to make a decision where we'd want to, and with increasing wattage, increasing cost. We also had options at this low end of different cutting areas, the kind that Alan had showed us and the kind that many on the market were. They'd cut around 6 inches square. And those 6 inches square would suffice for an awful lot of things, but you could also find for similar prices something that might have cut twice as large an area or 3 times as large an area. When we went back and forth on our discussion on this, we ended up deciding that space was a big deal. We wanted to be able to tuck this thing out of the way when we weren't using it. And so the smaller size, this 6x6 cutting area, is kind of where we gravitated towards. And we wanted some features that we were seeing coming onto the market, but didn't see in the low end ones, which had been out for a couple of years, such as end stops, so that it automatically knew where its 00 was, certain safety features, and maybe even an SD card slot, so you could actually not have to have a computer hooked up to it to run it, but that you could run it off of an SD card. That was another thing we had seen out there. And after research by several people, actually, we ended up finding this guy right here. This is the one we're going to be talking about. And just as a quick comparison to what would have been purchased normally prior to about 3 months ago, this is a 32-bit processor versus an 8-bit. Now, what does that mean to us day to day using this laser? It just means it's faster. It means it can process the images faster. It can do laser cuts faster. It's still the same power of laser, but you get better results because of the speed of the processor. It supports Gerbil. Gerbil is an abbreviation for, think of it as G code for CNCs or lasers. It's the control software. So it supports that, which was critical for light burn. It also supports pulse width modulation, PWM, or what we're referring to here as grayscale. So between supporting Gerbil and grayscale and getting confirmation from the author of Lightburn, we knew that this laser could be driven by Lightburn, or we were highly suspicious that it could be. We still needed to test it. It had some safety features that we hadn't seen elsewhere. As a matter of fact, let me just real briefly, if it stops moving, and so the laser is on in one spot for very long, it automatically shuts off, so that it doesn't start a fire. If you bump into it or tilt it for some way, it knows something is wrong, it will stop. If, for instance, it gets unplugged from the USB connector and is therefore not being controlled and moved, it will stop. So that's some really nice safety features that hadn't been seen previous to this. The one that we looked at seemed like the best cost power trade-off was a 15-watt machine, which again is around a little less than 5 watts actual output power. It did the 6x6 etching area. And I suppose one of the last features I'll point out is that it really did take apart and get put back together again very quickly. If you didn't use this for months at a time, you could store it in almost no space at all. And the amazing thing is that it was only $175. So how did we do versus what we were shooting for? Well, it's a diode laser. It was something that would work with Lightburn. It did support grayscale, and it was outside, unfortunately, it was outside of our price range. Oh, but wait, in a good way, $175. For the $175, you did get a 15-watt cutting 6x6, and it had a bunch of safety features. It did not have the SD card reader, but it is just fine. And we just end up with a computer being hooked up to it. When it comes, on the left-hand side there, you can see the packaging. It was really well packaged. All the pieces were wrapped individually and strapped. It was in very padded environment. I just can't imagine anything happening during shipping. And I said within 30 minutes, they say within 10 minutes, I was up and etching. So there on the right-hand side, you can see my laptop being connected to the Ortur and my first cuts of Mary Russo's signature. Here are some samples that we'll go to in a little, but right now I want to stop sharing that screen and I want to go to the browser. So let me bring a browser up and just show you what we see if we were to go to the website. And I'll put this link into the post that we'll have for this video chat, but this is what you'd see at the website. Let me take you to the top. Here's the basic deal from GearBest. Okay, this is the $175 for the laser. It ships out of Hong Kong or China when it ships, and you can hear many stories on this video chat about people who haven't received it yet, but we know what that's all about. And you can choose different plugs and different powers. And so here, for instance, we have $175 for the 15 watt. Up here, you can see it's 15 watt. And then if I choose this, I can go to the US 20 watt right here, and you see that the price is $239. Now, some people would feel that's a very reasonable trade-off. I just happen to have not gone there. Let's go down this page just a little bit, because if you are curious about this laser after this talk, there's obviously the discussion forums where we can discuss this more, but there is a lot on this page. For instance, here you can see a speed test comparison. This is where it really makes the point that 32-bit does produce results faster. This is a video that shows you all sorts of different materials being etched and a few that are being cut, so you can actually see it in action. Of course, you get all the specs, no surprise there, but this is something that should be of interest to you folks. This right here, you can click on and you can get them all the resources, the manuals, the drivers, the software, everything is available. Right now, if you were to go there, you would be able to get access to all of that. And if you're anticipating your laser any day now, that would be probably a fun thing to do. If you go down through here, you get some lovely views on what this thing is and can do. Some specs. It does not etch as fast as this picture is showing. And I want to scroll down here just to make the point that here is an example of where if it moves, so he's going to pick it up on the left-hand side, and when he picks it up, the laser stops. On the right-hand side, if the USB plug is undone, the laser stops. If it somehow ends up being stuck in one position, it stops. So those are those safety features demonstrated. Here are some views on a variety of carvings with the 15 watt and cuttings. And just to set your expectations, cutting is not the forte of this laser, okay? It will cut, but it cuts feeble stuff. It'll cut paper, it'll cut fabric, it'll cut very thin veneer. It will cut, but keep your expectations really low on this thing. And if we just get to the one chart I want to get to, oh, there you can see what a 6x6 area kind of looks like relative to the machine itself. Here's the assembly. It really is this easy. If you look at the upper left-hand corner here, those are the components you're going to assemble. There is the Y-axis, all assembled. There is the X-axis, all assembled. There is the laser head, and then there are some bolts. You end up mounting the laser head onto the X-axis right here. Then you plug it in to the controller. You then put the X-axis on top of 4 bolts that are in the Y-axis. You put the nuts on top, tighten it up, plug in a couple more things here, and you are done. So when they say up and running in 10 minutes, I think they're probably talking about the assembly of this thing. It really is fast. This is just a comparison with the other lasers that are out there. And here is the chart I was trying to get to, which just shows you what you can expect to engrave or cut for various power lasers. Mine is the 15 watt. And I find that this is a pretty credible list right here for what you can cut. I haven't tested 3 mil cork. That's the only one that I would have some doubts about. But I've tested most of these other ones and they work fine. And of course, you can etch on all sorts of things. Okay.
Travis,
this is one of those.
Comment.
Yes.
Could you, when you're done with this little section, could you go back to show the part that it enables moving up and down? You know, you had that diagram of the machine being assembled.
Oh yes. Okay. Here.
Yeah, right there. If you would just kind of highlight that part with the you know, part number 2.
Here.
Yeah, that's it. And that plastic part right next to the wheels. Yeah, that.
Yes.
Okay, so I'm going to show you a picture of that. It's going to be hard to visualize exactly what it is and where it fits. There is a slot in that that allows you to move the laser up and down about an inch or so, inch and a half. And so if you want to talk about the Z-axis, that's the part that I'll be referring to later.
Good point.
Right.
Richard, please feel free to jump in at any time, okay?
Be that honest right now. We want to be honest all the time, but
Hello?
sometimes it's better to wait for your honesty until you get some paperwork.
Somebody might want to mute. There we go. So just over here is another picture of what Richard was talking about. This is where that same 2 slots were that the laser mounts on. He's going to be pointing out something that's really important when we get to that. In any case, I just wanted to show you that this is a very informative page. And I also wanted to show you that if you were to click on that link and go to see the documentation, here, for instance, is the English language of the manual. So this manual right here goes through and talks about the entire assembly process. It talks about the software installation. Every step is guided through. In addition, there's the tables of reference for what you can cut and etch. So here's the 15 watt right here. If I click on that, that's what I was just showing you, but for all 3 powers. So this is what you'd set for speed and power for each of these different materials. So it's a reference sheet. If I were to go 1 level higher, then I could take you into how you set up light burn. And light burn, it's a very straightforward process. It's just a matter of 4 screens, which are the exact screens that you'll see here. And this is what you would do on your version of light burn once you get your laser. Yeah. Choose Gerbil, choose the serial port, define the dimensions, the 150 by 160 for the size of the bed, plus naming it. And then lastly saying where the origin is, which is the bottom left, and telling it to auto home when it starts up. That's all there is really to configuring light burn. Now, there are other things that need to be done, like for instance, there's firmware. When you get your laser, you may well need to upgrade the firmware. It's not a very difficult process, but it's important to do because it only is supporting light burn well with the newest version of firmware. So that's something that's described. Again, this is all just at the link that we had available to us from GearBest. We also have some Windows drivers that we need to install if we're running this on Windows. And there are Windows drivers for different versions of Windows, 32-bit and 64-bit. So all of that is available to you right now, and we'll put a post on the discussion board. But what I'd like to do now is just pause for a second, see if there are any questions.
Well.
Okay, that's good.
This is Rob.
Yep, go ahead.
Yeah, hey, real quick, I thought I saw some back and forth yesterday or the day before with the manuals already put on the, you already have the manuals put on the group website or something?
I think we did post that a while back.
I thought just a couple days ago when I was catching up with things. So that's why
Richard, didn't you post a few screenshots? You're muted right now.
It was very selective about you know, one screen and one setting that needed to be adjusted. I didn't post the whole manual. I've posted a variety of other comments. I'll have to say that.
Well, maybe it was a link.
Thankfully.
Maybe it was a link, and when I clicked on the link, I went to the same place you just showed us, Travis, and then I did an extract all kind of thing. It was a zip file in my Dropbox. Maybe that's what it was. So
yeah, and it is in the Dropbox, and I will post the link right after this
you put
in the discussion boards.
All right. I was just trying to remember.
Okay, good, good. All right, let's switch over to the camera real quickly. Let me do that. Okay, so when you get your kit, it includes all of this that gets assembled, of course, but it also comes with some samples that you can be etching on and cutting. Comes with a a little wrench, something for applying surface coatings, and also a marker for when you want to etch off black. When you see the video that shows etching on different things, some of them are metal, and that metal is been coated with this black marker. So it's not like rocket science, but they provide it to you to give it a shot. You also get these super stylish glasses right here. And I have to tell you that while I might be a little bit mocking of the way they look, it is really recommended that you wear glasses. And Richard made a really good point in a post recently, which was if you expect to have other people around when you use the laser, get another pair. I know that he ordered some and I had some from before, but this is visible laser light. Unlike the CO2 lasers, which are invisible light, this is visible and you need to protect your eyes from the frequency of light that they have. Also in the box is this user manual, which we saw online, but that you'll get a printed version of. You get a list of all the different cutting details, which we've already seen online. And you get a list of all the parts that you would expect to see in the box. Okay. Now let's move on over to the laser. I mentioned that there was the laser itself right here, and this is the x-axis, and this is the y-axis here. This is the slot that Richard's going to be explaining a lot, but it's right behind the laser, okay? And I just want to show you that there are end stops here. So here you can see an end stop. That's for the Y, so it triggers when it gets bumped. And then for the X, it's right up here, this little black knob here. So the end stops are there, and here in the back is our controller, where back here is where you see the power, the USB. This button right here is on and off, and it's protruding, where this one right here is a bit recessed, and it's the reset button. But that is, to a very great extent, the laser. Now let's take a minute and in action after I give you some demos of what the results can be. Here is one of the first things that I did when I got the laser. You have to focus it. And so here you can see we're quite out of focus, or we wouldn't have had these wide etchings here. Then as I got it closer to being in focus, I got thinner and thinner lines. And so eventually, I think it was this one right here, distance, and that was what I had for being in focus. I then went ahead, you saw my first etch, which was Mary Russo's initials, but I had some thin veneer, and I wanted to show that it could cut it and etch it. So those are some things that I was able to do. These are a combination of 1/128th and 1/64th inch thick veneers, and there's a quarter there to give you a sense of scale. Here you can see a variety of tests. Let me describe it to you real briefly. Underneath each of those stars is a number. That number is the speed at which it was moving in millimeters per second. So you can see on the bottom far right, it was very slow, 2 millimeters per second, and the first three are just terribly charred. The fourth one is also slightly charred, but it was at least the right depth for normal veneer, 1/32nd, 1/40th of an inch. On the second row, I kept speeding it up as I went from left to right. So 10 millimeters per second, 15, 20, 25. And I measured the depths of the etch in each of those cases. The far left was 1/64th. The second from the left on top was 1/128th. They're very clean lines. The recess is just right for the right thickness of veneer, which I'll talk about in just a second. But that was a test array, so that I could then see if I could cut some veneers to go in it. And there's a company called Lenderlink. There are others as well that do micro thin veneers. This right here is olive wood. So if Mike's on the call, he should be happy. This is 1/128th of an inch thick. This is 1/128th of an inch thick. These two right here are 1/64th of an inch. These are easily etched using this laser. So for inlay purposes, there are some good possibilities. And I wanted to see what this company had to offer. So they sent me a catalog of all of their samples. And they're going to also provide me with some samples that we can sort of dole out amongst our group here of people who have these lasers so that we can try it out. So any questions about that before we actually get to the laser doing its thing? No? Okay. So now let's see what this laser can do, huh? Toggle.
Travis, do we need to put on our laser protective goggles now?
Right. No, you don't. Let me bring up my Lightburn. I'm going to just show you Lightburn real quickly so I can tell you what I'm going to do. This is Lightburn, of course. I'm going to do 3 things for framing. I'm going to frame a box. So you guys remember that right here we have the box, and that does a rectangle around our etched object. The circle is what I'll do next using a trick that Richard just shared with us. And that does a rounded framing. It's not exactly the shape, but it sort of does the outside contours, you know, the more general region. And then I'm actually going to do a low power cut. So this is what we're going to be etching, but I am going to begin with do a cut over here, which we're going to output only 2 watts. So I'm going to output this one right here, and it does 2 watts at 50 millimeters per second, and it is this blue line that you can see. Let me make it more obvious by hiding the big thing. So it's going to do that trace right there. So we can see exactly where it's going to be on the wood. And then lastly, we're going to come back and we're going to output the scoring of the whole thing, which will produce this right here. After which then we can take some Q&A and hand it to Richard so that he can continue with this odyssey we're on. Okay, so let's position the. Okay, so the first one was to actually frame it. And there you can see that it's actually framing the rectangle. Okay, let me move it over so you can see it a little bit better. Now I'm going to do the circular button framing. And you can see it's not a rectangle. It will take the general contour of the outside of this. And I'm holding the shift button down like Richard told us. Okay, so that one took the overall contour. But now I'm going to output the exact shape by doing a 2 watt, very low power, excuse me, not 2 watt, 2% of my 5 watts, so that the laser light is on. I'm going to do it relatively quickly. So now let's go ahead and just output the shape of the elephant itself.
What's the purpose of this first light cut?
So Richard in particular has some challenges. He does turned objects, and he needs to make sure he knows exactly where on these surfaces his etching will be. And so if he can actually trace exactly where the laser will land on his objects, then he can feel confident when he hits the actual etch button. People who have shapes on which they want to etch, but those shapes are irregular and placement is really critical, then that's really useful to them. Most of what I do is cutting things out of another material, so it's not as important. But if I had a plaque, for instance, that had a beveled edge, and I wanted to make sure that everything was perfectly square, or I had something cut out the shape of a fish, and I was going to etch features on that fish like scales and eyes, etc. I'd want to make sure that everything was perfectly positioned inside the laser cutting area so that I'd get the result I was expecting. Okay, see all 3 of those framings. Now I'm going to go ahead and just start this etching process. And I'm putting my glasses on. One of the things I remember Richard commenting on was how it obviously does produce smoke, and there's no smoke extraction system here. I use it in the garage. I happen to like the smell of burnt wood, but it could be an issue if you're using it indoors. It's
What
kind
are
of,
the power settings you're using right now?
on this one, I believe it is 12 millimeters per second and 100%. It's kind of fun to watch this blue light. It's just, I don't know, it's as though you can see the beam itself because of the way it goes through the smoke. And did I mention that this is only $175? I'm still
That's really
kind
good.
of flabbergasted. I think Paul just asked about some fume extraction, whether there is any. There isn't any on this system at all. There's one fan. Let me see if that's true. Nope, there's not even, oh, there is one fan at the top of the laser, but that's simply for keeping the laser cool.
That's really good detail.
It really is. It's beautiful. Let's get a little closer to just be able to see what the results are so far.
I'm just going to underscore the smoke story, because that's when you see smoke, those are really small particles, and they go right into your lung. And I triggered some asthma reaction to it when I wasn't being careful. So I encourage you at least have the garage door open, and I hooked up a little fan to kind of blow the smoke away, at least dilute it. And I'm wearing a mask now, so just a caution.
Yeah, I got a fan on mine and put beside it to blow the smoke away. Also because they say eventually the smoke can cloud up your laser lens if you don't blow it away.
Right. That's actually a really good point. We say that all the time about why we have the compressor on the lasers at the shop, to blow smoke away from the cutting area. It has several benefits, but one of them is to just ensure that we don't get smoke on the lens. And yet that's even inside of a closed cylinder. This is out in the open, so it'd be even more susceptible to getting cloudy, I believe. So that's a really good point, Richard. Thank you.
Hey,
By the way,
Travis.
guys, Richard has one of these, a variation on this as well. He has it's sort of a CNC/laser, and he's the one who just upgraded. Richard, you went from what wattage to what wattage on your laser?
I went from 15 to a 20 watt.
Got it.
Did that make a
So do you have a
difference?
question out there?
Yeah, I have a question. Regarding the smoke on the lens, I thought those lasers had a fan, a cooling fan blowing through from the top to the bottom. Is that what you have on that, or is there no fan at all cooling the laser itself? Are you there?
Yeah, I am, but my earpiece just dropped out of my ear.
Ah, okay.
Can you hear me okay?
Yeah, I hear you a little bit. Sounds like your mic was in you.
Yeah, I think the mic was in the other one. Let me switch it. Okay, hold on.
So the other thing, while you're doing that, the other thing I brought, Paul had mentioned the smoke, and what I was wondering if they sell these solder fume extractors for soldering stations, because you know when you solder, there's lots of fumes. So they sell these little, and there's a bunch you can make even. There's DIY ones, but they're just for sucking that air and filtering it. I wonder if a fume extractor could work near this. A soldering gun fume extractor would work well.
Yeah. Can you hear me at all, Doug?
I can hear you okay, yeah.
Yeah.
Okay, so I'm just going to tell you that I'm looking at the smoke as it rises from the wood, and there must be smoke. There must be, the fan must be getting through to below, because it is blown somewhat away. Okay, so
Yeah.
I haven't analyzed it, but I suspect you're correct.
Okay.
So it's going to continue to do this, but I would like to turn this back over to Richard so that he can continue with this process here. Richard, why don't you go ahead and grab the screen and start talking to us.
Right. Okay. Can people confirm that you can hear me and then you can see a screen?
Hear you well.
Dallas,
Yes.
just put a thumbs up or show me. Here you go. Thank you.
I hear you.
Okay, great. So I'm more of a wood turner than a flat work person in my San Diego shop. And so what motivated me to want to get involved in this stuff is to be able to first, sign the bottom of my bowls. It's a wood turning tradition that, you sign your work on the bottom. And so I've been doing pyrography for that. And that's kind of a pain in the ass and not very elegant, and I'm not that good at it. So I was kind of looking for something a little more elegant, and I figured this would be a justification for a new tool, right? That's what we're all looking for. The other thing is that I've seen some very elaborate designs on the outside of some bowls that had to have been done by a laser. One of the things that happens with wood turners is after you've turned for a while and you get really comfortable making the form, then you move to embellishment. That, making the form is, becomes a little more routine. And so you have all kinds of people doing carving and engraving and coloring and tinting and all kinds of, embedding crushed stone, all kinds of things to make it more decorative. They're embellishments. So I was thinking that maybe there would be some embellishments that I'd be able to do and kind of do a combination of the craft of the turning plus some embellishment. So that was my motivation for getting it. And there are some things that follow from that. So for some reason, mine came early. I don't know why. I know I ordered mine after Rob had already ordered his. So I'm not sure why I got mine and he didn't get his. But I paid nobody any extra to do it, just to be clear. I have struggled, to be fair. A lot of mistakes are mine, but I've had a lot of interactions with the Ortur people. And what surfaced from that is that Ortur is working very closely with the guy from Lightburn. And that really has been a key part of sorting out the problems that I was having. So the idea that we're using Lightburn to control this laser is really terrific. I have posted a number of those lessons that I have from how you set up the machine and buttons you can push and things to look for. I'm not going to talk about those now. It's on the forum. It would have been meaningless now if you don't have a machine to tinker with. But when it comes, I sure would encourage you to look at some of those things because you too might have the same problem. So I'm going to do is show you some stuff I did with lettering and discuss what I'm going to refer to as the Z-axis problem. And I can do that if my slide flips. No. Here we are. So I just wanted to show off something that I had made as an example of what I had aspired to do. This was not done with the Ortur laser. This was begging for time on my neighbor. Didn't have to beg very hard on my neighbor's laser. So I turned the platter. I knew roughly what size I wanted it to be to make sure it fit in the laser itself or would fit in the laser in the future. So, and then when I did the work on the platter, I made sure the area around here where I knew I was going to want to engrave was basically flat. And the area in the center where I wanted to engrave was going to be basically flat. And then when I did my design work, I made sure that the design work fit the specifications of the object I was going to engrave on. So like this was a little big, so I shrunk it down because the curve, that I ended up with here was a little bit more and they didn't want to take any chances. And this is a different font than that one. So I had to do the kind of wed the text to a path to get that all arranged. Similarly down here. But then anyway, this is what I ended up with. This is what I've been hoping to be able to do for, going forward. But then I got my machine and I figured out, let me try some other things that I might do. So I figured, well, if I saw things about engraving business cards. So I just took one of my old business cards and then scanned it and then brought that into Lightburn and burned it just to see what it would do. And, you know, I think it came out fairly crappy. And so I'm sure I could have tinkered with it more, but I decided, it was not that interesting an idea, and it didn't turn out that well. So next project, please. So then I thought I'd just see what happens if I just did some simple engraving of letters. And so, you know, did the standard stuff. This is just the outline, the line, and then this is the line plus the fill. So it's the scan. And you could see that something's strange here because I didn't have my text line up here in my design, and I certainly didn't have this here. So I was trying to figure out what caused that to happen. And the answer is that basically when the laser starts doing the outline of the line, especially depending on certain speeds, the whole thing's really jumping around. And I think what happened is that the wood shifted a little bit. And so then as it continued to go, it was malaligned. So as a result, whenever I'm doing something in the wood, I'm gonna tape it down so that I at least know that the wood is stable in location. So then once I figured that out, then I said, all right, now the wood is secured. What I'm also gonna do is apply some of that sticky tape to avoid the smoky appearance. And that I had found was really critical when I did my testing with Sam. And it really made a big difference in how pretty the characters come out. So it's a little bit of a pain because you've of course got it, once you have the tape on, you got to fish the tape off some of the smaller spots. But it's well worth it. Again, this is the line, and then this is the line plus the fill. And I think it looks really, really good. It's definitely acceptable for most of the things that I'm going to want to do. This is on poplar, just for the record. So then I decided I would kind of go, try to make it a little bit darker. I thought some of these things maybe could be a little darker. There was these little light spots in there. What could I do to get rid of that? So that was at 2550. So I juiced it to 2570. This is in oak. And let's just say that really burned its way through here. And in fact, I later come to understand what actually happened here. That's a little bit of a fire. That intense smoke is a result of that. So then I said, okay, well, I'm going to back it down, but now I'm going to start doing a curved object. And this is a curved box, kind of like a clam. It's curved on both sides. For the positioning, I just let it do a light rectangle on the actual board that I was going to secure it to. And with that square, I was able then to align the edges of the circle so that it would cut concentrically. Can also center it in the center, but I've been having trouble figuring out my origin and how to center things and do other that stuff. That's the only reason I didn't do that. That will come, but has not yet arrived. So I let that run, and then, the lettering here, and this is even on a curve, I think is beautiful. The problem, of course, here is that this is not so beautiful, which is where it caught fire. It wasn't a big flame, but I could see as it would hit, it would be just like a little flame, and then it would as it would move, the flame would go out, and then it would ignite something next door. So, but this, you can see this is the clamshell where the burn occurred, and you can see just for dimensional purpose, that's a pretty good curve. And yet the lettering turned out okay, except for what happened here. So as best as I can figure out, what happened there is that the laser's not, coming down perfectly perpendicular to the platform. And so the laser's kind of hitting this a little more tangentially. And because it's not straight on, it's tangential, it's not implying quite as much juice, but it's enough juice to light a fire. In other words, it's enough to light the tape, but not, burn a clean edge in the wood. That's at least my current hypothesis. It's not off by much, as you can see here. So that's kind of a challenge and I'm not quite sure how to resolve that. Of course, I'm open to other suggestions as to, what might be the cause. In any case, just thinking about what I might embellish, I think there are possibilities. This is just a piece that I made that's basically flat. I did some embellishments doing some wood burning. These are cracks, you know, I did a little work to kind of prevent the crack from propagating. So I could certainly do some of that, at least the pretty stuff, like the leaves with the laser. I think the flat up around here on the top is flat enough. And this little platter I just kind of made as a throwout. I didn't like it. I thought it was pretty ugly. I didn't even sign it, but I'm thinking, whoa, wait a minute, this is flat. I can do some embellishing here around this flat surface now. That might be something really interesting. I think the challenge is, you can see if when I'm bringing one of these objects to laser, I want it to be right the first time. I don't have it, I spent a lot of time making that. And the last thing in the world I want to do is have an embellishment and have it, you know, catch fire or do something. Then I got to throw the whole thing away. So it's sure different than just starting with a plain old piece of wood. So, yes, sir.
Quick question. So, if you were going to do something like on that little platter, which has already got finish on it, have you tried doing any cutting of anything that already had finish on it? And how does that affect it?
Yeah, that was my first test of this, and the proof that the laser was going to be cool was that I made some pens, and with the pen, the way I did this was I just put the CA finish on the pens, and then was able to engrave just a text message on the pens, and it came out beautifully, and you know there was no ash or anything else. So at least for CA, I haven't worried about it. And the real answer to your question is that this is a waterlox finish. And so what's going to happen with this, I don't know. Maybe it'll catch fire. So I don't know.
Not funny, Richard.
Yeah. I think the key is I'm going to need to make test pieces with a similar curve that I'm going to burn first. So it makes the project of doing the embellishment quite a bit more, have quite a few more steps, but you know, if it's really cool, that's okay. It's a hobby, right? Okay. So now the Z-axis problem, and the Z-axis problem is obvious. If you look at this ball, if I wanted to do something here, I need to get the laser high enough above it that I can hit it. And if the laser only, can hit down here near the bottom, then I can't engrave the top. Nor, in fact, for that matter, can I engrave the bottom, because I still need to have the laser up at the other end. So that's what I'm calling the Z-axis problem, because it has very limited range. The way you can adjust it is this little spot here. There's this slot here, and you can move it up and down, about an inch, inch and a half, something like that. So if it's a thin platter, it's probably going to be enough. But, I really need at least 6 or 7 inches of play to go up and down. And one of the problems is that this device here, with this current setup, is really only held in place by these 2 screws. So there's a certain amount of play where the laser can move in different directions. That is, shall we say, undesirable. So I'm not quite sure how to handle that one. The suggestion I've made on the forum is that maybe you could build, design one of these pieces that would have a much larger slot and 3D print it. And then that might solve part of the problem. But then, of course, you need to do something else to deal with the movement in the Y and X axes for that piece. Now, the company, when I've corresponded with the company about this, they said they're coming out with something that'll give you more Z-axis play, but I don't know exactly what it was going to be, and we'll have to see. Maybe your new machines will have it. In any event, that's the problem. So I thought, I was trying to think through what could I do. So here's an example. The laser. Just imagine the laser sitting here. I would kind of make a support that would be on each side. It would be one on each side, and the laser would be attached to this triangular piece, and this triangular piece would slide up and down. And just by sliding up and down, you'd be able to raise the laser up above the piece that you're working on, which would be down here. The only problem is the cables come out of the laser off that side, and you therefore can't, there's no mobility there because of the positioning of the laser, and there's no room on the inside of the laser to flip it around. So this basically doesn't work. Again, and here I'm putting these ideas out there, see if any of the engineers or more creative people in this crowd can come up with a better solution than I have. So here's try 2. Basically, the idea in this one is the whole laser frame, the whole thing, both sides, the laser, the whole deal is sitting up here, and there are legs on each side. So the whole laser is raised above the platform that this whole thing sits on. And then there's a platform, this platform that's going to hold the work, and this goes up and down like it's a shelf. And it occurred to me, you can just put, it's just a shelf, just put some shelf brackets in here, and then you'll be able to raise and lower it once the whole laser is elevated. Unfortunately, part of the requirements is that we now know is that the platform really needs to be square to the laser beam, or you have more of a chance of the burning. So the platform needs to be both adjustable but rigid, because remember the laser kind of, as it's doing its thing, kind of jiggles around. And so if it's jiggling around, then the platform is going to jiggle around. And of course, you need to have some way to secure it, but that's easy because I think I just use blue tape and secure it to the platform. That's pretty much the story. So that's basically my odyssey so far, this plus the stuff that's on the web. So I'd be open to whatever questions you might have or suggestions.
I was looking in the list of questions that was put in the chat, and Ian was curious what type of tape you were using. Was it the light tack tape as we use in the shop or something else?
For the lettering, on the burning, it's that light tack tape from StuMac is where I got it, per Sam's suggestion. And it's available. I put a link in that in one of the things that's on the forum. There's a link to the exact stuff that I used, but it's the light tack tape.
And there was another question of the focal length. I draw that one to your attention because I remember when you and I were looking at your slides yesterday, there were 2 numbers that you had. One had to do with the vertical movement of Z, and the other had to do with how high the lens needed to be above the workpiece. Do you have those numbers here still, or do you not?
Yeah, the number that is that's sticking in my mind is that the base of the laser thing, not the lens itself, but the base of the laser thing needs to be 55 millimeters above your focal point.
Perfect.
And so I just cut out a piece of wood that's that length, and then I don't measure it. I just use that as a jig.
Oh, the high-tech measuring tool. Yes.
Yeah, right. And then I've adjusted the lens. The adjustment of the lens is kind of flaky. I mean, it's not what I expected for focusing. I mean, I've worked with microscopes, so I know what focusing is supposed to work like. And this is just kind of like, it goes from fuzzy to kind of a little less fuzzy to more fuzzy, and you kind of go, yeah, okay, I guess that's it. So,
did you get the 55 millimeters from your testing, or did you read that somewhere?
No, I read that somewhere. I think
okay, good.
I think that's in the manual.
Okay, good, good.
Be corrected on that.
Let's see, Doug had a question. Oh, it wasn't a question, it was a statement. Any other questions for Richard? Okay. Anybody want to see what the final results of the laser scoring
I
were?
would just encourage people to at least get on the forum or think about this idea of how to get more Z-axis out of this thing.
Hey, Richard, how about extending that piece that the laser mounts on with those 2 slots? It looks like a flat piece of acrylic that's holding the wheels and the laser. I don't have one of these machines in front of me, so I was wondering if you could cut a new piece of acrylic that had, say, a 5 or 6 inch extension on where the laser is currently mounted.
This piece right here.
Right. Now, just think, what if that was 6 inches higher?
yes, I think that's definitely one of the things that can be done. 6 inches higher, longer slot. I think that's it. The question is going to be is to how much it, you know, makes it out of perfectly vertical alignment. But I do think that's the place to start.
Yeah,
So,
and what
you have a 3D printer or can manipulate some acrylic, if you'd like to test out that idea, I'd be happy to be an additional party. There's a fair amount of taking things apart you need to do to get at that, but that's achievable. And I have to say, I'm going to change these. These are this kind of funky Phillips head stuff. I'm going to change those bolts out for something easier, you know, like a machine head, something.
Right, I could see that piece that would be extended up being wider, and then having a few slots in it, so that we could put a couple of pieces of acrylic to make a kind of like a semi box to kind of enclose it, so it would be able to slip in it. That would also make it more rigid.
Sounds good to me. That's great.
Sounds like
That's why
you'd be
we have
happy
a
to try
group,
it out
so-
for you. Yeah, exactly.
Yeah.
So,
Hey, Richard, if you want to go ahead and let go of the screen share, then we can. I think it's up at the top at options.
Got it.
There you go. Okay.
Got it.
Richard, this is Rob. Hey, you mentioned in the forum and then on your presentation today that the laser shaking a lot. Is that a feature of just being loosely tied down, or is it even if you try to hold down the laser, does it shake?
Well,
And does
ironically,
Travis have the same challenge?
yeah, ironically, I'm finding it's really interesting because, as you can see, Travis's is not secure. He's just sitting there quietly on the piece of wood, and mine is screwed down. It ships with a little angle brackets, so you can screw it down. And I screwed it down to a bunch of 3/4 inch plywood. So I'm wondering if having screwed it down is making it move more, or maybe it's the speed of the line cutting. I haven't quite figured that out as to why mine, but mine, when it kind of does the scans first for the lettering, and then it outlines each letter. And as it outlines each letter, it's kind of jiggling around really impressively.
Yeah.
So-
The way you describe it, Richard, because I remember when I assembled mine, there are ways of tightening it up a little bit. And so maybe that's a step that still needs to be done on yours, because as you described the shaking, I haven't experienced that. Let's take a quick look at what we've got here. You can see that this is the way the vectors were intended. This is the way you would hope that this thing turned out. So I don't get the shaking, but folks who do get the shaking should probably talk with those of us who've tightened it down. You can tighten belts, for instance. You can tighten certain tensions between the wheels and the linear rail. There are just a few places where you can go tighten it down a little bit, and then the result is, as you do here, lines that are where you expect them to be. Okay, I think that's pretty much it. Anything more, Richard, before we start to wind this down with any other last-minute questions?
No, but I'll be calling to find out how to tighten things up.
Oh, okay. Okay, that sounds good. That sounds good. Let's switch back and see if there are any other things that people want to talk about, mention, ask questions about before we close down.
I have a question.
Sure.
I noticed on the GearBest website that Ortur has another model that has a much bigger frame and a bigger work area. Did you evaluate that, and why did you choose not to go with that one?
It had to do with exactly what you said, the larger footprint, the larger space that would be required to set it up. It really was an ambition of those of us who were going to be using this for just etching occasional work pieces, that it be something that gets tucked away. We're all living in these small spaces, and if we didn't have to keep the frame permanently taking up a footprint, then we just chose not to. So, I mean, there's no right or wrong decision. It's just where we landed, and I took the leap first to get one to test it out and make sure that it worked with light burn, et cetera. And that's simply the one that I got. There's nothing wrong with the larger one. It's just larger, that's all.
Okay, thank you.
Now, was that you, Paul?
Yeah, that was me.
Cool. Okay, great.
Travis, it's
Any other
Dallas.
questions? Dallas,
I've
go
got
ahead.
Yes. Has anybody done anything with using a Octoprint sort of a server to connect with the laser, so you don't have to be tying up a computer for longer scans?
Oh,
I've used it.
no,
for
but that's a
3D
great
printing.
question. Hey, Doug, tell them what you do with the 3D printing. You've got the Octoprint working with yours, right?
So yeah, so one of the things, my issue was I had 2 3D printers, and I wanted to basically just, you know, be able to control either one anytime, and then also free up my laptop. So yeah, Octoprint is basically a G-code sender. It just, it brings up a web page and you send it your G-code, and then it runs it. That's pretty much what your laptop will do. It just sends the code. And the cool thing is that it can be configured to be started with a different HTML URL and a different config file. So that's what I was able to do. I was able to tell it to have 2 different ports. Like, you know how port 80 is your standard web port? On Octoprint, I think the standard port is 5000. So I set up one version of Octoprint that started on the standard port 5000, but used a configuration for one 3D printer. And then I started another instance of Octoprint that started on 5001 with a different configuration. So I could just let this little Raspberry Pi run 2 printers simultaneously.
Cool.
Well, that'd be interesting if we were able to do that. That would free up a laptop, and for longer scans. You're doing a bunch of raster that could take quite a while with this small printer.
Yeah.
Sounds like a great hack project for the community, Dallas. I'm with you 1000%.
Yep.
Richard, you had your hand up.
Yeah, I just, on the larger frame, I just want to remind you that with a larger frame, this whole thing is cantilevered. If you look the way the laser is, it's kind of hanging out at the end of a long bar. So depending on if they've made any other structural changes, that might mean that there's a little more motion or a little more problem with alignment when the laser's cutting at the end of its range to the beginning of the range, which might be why you got the larger one, to be able to do that. So I don't know if it's going to be practically important or not, but just it's a consideration.
Okay.
Yeah, the larger
Any
one
other
has,
questions?
2 frames.
All right. So let me just run one last thing by you folks, which is on the topic of lasers. I was thinking about what might make a good special interest group topic. And it occurs to me that while we don't have the shop available to us, and we're here because we love what lasers can do with wood and other materials, it might be fun to see what people have in their homes for CO2 lasers. And so I've lined up, I've only lined up 2 of these 3 people. But the idea would be for those 3 people who have distinctly different Chinese lasers to actually tell us about their lasers and allow us to ask questions about them. Very purposefully, they're 3 different sized beds, 3 different power levels, and 3 different cost levels. But they range from $1,200 to $4,000. And frankly, I would love any of them. So the idea would be to have a session like this, but we would actually hand off to each of the 3 people to give us sort of the background from a specs perspective, and then to opine on whether they liked it, what kind of hacks they've done to it, what changes they'd still like to make, and give us a sense for what it is like to have one of these lasers in our homes and what to expect if we were to buy them. By a show of hands, using the icons, can you let me know who on this call would be interested in that topic? This is also a test of, so Dallas knows the buttons well. How about some more thumbs? Oh, got some more, okay. Okay.
What
I'm still looking at,
What
Mike
button?
McKinley, come on, buddy.
What button? What button?
So Dallas could tell us. Could you tell us where it is, Dallas? How do you do the button?
Yeah, you need to go to the bottom of your screen. You get a little pop-up, and on the right side, you're going to see something that says reactions.
Uh-huh.
And it gives you two choices there, of either applause or a thumbs up.
I see.
And we can move on as soon as Mike does a thumbs up. There's Alan. Good. Oh, there we go. Ed, Gary.
I'll do a thumbs up.
There we go. We have arrived. Mike has given us a thumbs up. Okay.
Holy cow. I'm not sure. I'm worried. Okay.
Don't be worried. Don't be worried. Anyhow, I think that's it for today. Unless there are any last minute questions, the idea is that, I'm sorry, go ahead.
One last minute question. You had a map over your head there. I'm just curious, what's that of?
It's 1928 San Diego.
Oh, okay.
I'll send you a picture.
All right.
We're trying to do these kinds of things on a more regular basis, primarily because we're all isolated, and this is just a chance to interact and learn. Dallas has done some things, Gary has done some things, I've done some things, and yet it's not really just the three of us who are intending to put these things on. So for instance, Mike McElney I've approached about talking about all of his outreach efforts with the fire department, with the animal shelter, with the police department, the kinds of projects he's done there. We have quite a lineup of ideas, but the ideas are not for the people who've been staging these things to do them. They're to get the whole community involved. And let me tell you, when it comes to the technical hurdles, you guys being here on this call have basically done everything that you need to stage one of these things, because we can take if you have a topic, please suggest it to Dallas, suggest it to Gary or me, and we'll get it on the agenda. I don't know whether Doug putting on his face mask there is suggesting that he talk about face masks, but I suppose that's an example of an agenda item. Anyhow, with that then, I'm going to end the recording, and I want to thank you guys very much for participating. I personally find myself in a house with my wife and dog for hours and hours on end, and it's great to see all of you and interact around these topics that I know we all care about. So thank you very much.
Hey, Travis?
And yes.
Is this recording going to be available? Are we going to be able to access this?
Yes, thank you for saying that. The way we do this is we record it, and in addition, we will put some timestamps in a text above the recording that says, if you wanted to hear what Richard had to say, if you wanted to hear what Travis had to say, if you wanted to hear the Q&A session, go to these different times. You can see an example of that right now if you just go to SDFWA.org and look at the ones that have been done. You'll see more of them. Gary has one that's going up. I have one that's going up. The idea is to post them in the discussion boards, allow people to comment on them, and they're linked to YouTube videos. And that way we keep the conversation going, and we leverage the storage of video that's provided to us by YouTube. There are a couple other hands up here. Let's see, Rob.
All right. Cool.
I guess Rob didn't intend to ask a question.
No, I did. When you said reactions before, I don't have a reaction button, so I put my thumbs up with my hand.
Okay. Well, appreciate the reaction. Alan? Alan? So I was right. We really are done. All right, everybody. Thank you very much. Talk to you again soon.
All right. Good. Thanks. Good job.
Thank you. All right. Thank you. Bye-bye.